the IT experts. Now imagine if you can have an efficient, stable, and compact robot design that describes ours. War ahead.
Our robot looks so cool. Because of the hard work we put into it, we came across many design problems before finalizing this one.
Our first robot design was probably our least favorite since it was very tall and it wasn't very compact and it couldn't hold a lot of the weight that we needed it to hold.
Our second robot design was a bit better. It had less jerking, but it still was slightly going off track. But with the third design, when it goes with thicker wheels, it can go perfectly straight.
Our design was flawed because of the wheels. They were so thin, it couldn't support the robot's weight. So we added wheel barriers to try to help this, but it wasn't that efficient.
Our third design is our favorite design. It is a compact design that has walls that make it intact and stable.
We fixed issues with balance and speed. We added new wheels which are shorter and wider, which can support our robot's weight.
Another big change is that we added walls. They not only keep it compact, intact, stable, they also have a place for our wires.
We like this design the most from our other designs. Since we added 2 gear systems at the front, we can perform multiple missions and use many attachments at the same time.
The coolest part of this design is that it's a hybrid between a box robot. It's not completely boxed around as you can see right here, but it is boxed around so it can stay more durable against missions.
Before, when we used to do slide and bench, the wires were up here, and whenever the cubes fell, they would hit the wires, making it inaccurate, making us lose points. But now all the wires are inside this box. Program efficiency is something we wanted to achieve while programming. We wanted our programs to be accurate and speedy. We were able to achieve this by running our programs block by block.
The way we found the ratio between speed and balance is that when we played the program, like Sharia said, block by block, we found out how much distance each speed goes with one rotation.
Let's talk about our attachments. This is the attachment we use for slide, and the reason it's different from other attachments is it falls using gravity. It is attached like this, and it falls down and pulls the slide guys back.
This is a multitasker attachment. It is used for bench. These are edges that hold the backrest. This angle beam pushes down the bench. These mechanisms hold the cubes, and then when triggered by the bench, the cubes fall.
This is the Basha attachment. It attaches right here to the front of the robot, and since it can do Basha part 1, 2, and it can do weight machine. The way it does that is that it can hold cubes right here, and it can go up and down.
This is the crate. It attaches onto the side of the robot and moves and adjusts with it. It pushes the project and health units into the replay logo.
We believe that any time in base is time we're not getting points. We minimize this by combining our missions so we stay less time in base.
Another thing we did is that since all of our attachments are very light, simple, and easy to attach, we can save more time there, and it helps with the inspection mission, so we get an extra 25 points.
Our strategy to get more points when doing a robo run is that we do the missions that give the most points first, then the missions that are further away from base, and then the missions that are closer to base.
The reason we use the multitasker attachment for bench first is that it can do bench really, really fast, and it takes a long time to put on and gets the most points in that time.
Thank you for listening and thank you for your time.